Hello, my name is Azim Edisham, and our project for Pickhack's 2024 this year was Priority Lens. Priority Lens is a website that is designed to take the top-down view of property and choose the optimal location for security cameras by taking into account the importance of objects around it. To explain the algebra behind this, I'm going to let Riley take it from here.
Hi, I'm Riley Carter. I was the one who did most of the back end and math here on the project. We have basically, after everything's done in the front end and all of the users have input all of their priority zones and buildings, they're passed as a list of objects to me, and I sort them out. We take all the buildings, we put them aside. Then we have all of our priority zones. We take those priority zones and we assign them a weight. We take those weights and those zones, we get the centroid of each of the zones and save that as an object with a weight and the point that is the centroid. Then we separate the entire workspace into 9 equal sectors. That number of sectors can be changed based on however the client would want to do that, however granularly they want to have the algorithm parse through their property or their area. Each sector will take all of the priority points in that sector and it will prepare a weighted average of all of those, and for each of those sectors they will get their priority point, which will be 1 point for that sector that has a weight that is the sum of all of the points in that sector, and that point will be the weighted average based on the weights of the individual points that are in that sector. Then we will find the nearest edge to each of those points. And once we find the nearest edge to each of those points, we will we find the nearest edge and we try to maximize the coverage of the cameras. So this blind spot in the middle counts as coverage because nothing can enter or exit without the camera seeing them. We take this priority point and we map it. We find the nearest wall, then map a perpendicular line from the wall to this priority point. Then make the ends of the effective view distance of each of the cameras meet at a point on this perpendicular line that maximizes the amount of area that the cameras cover, which may change based on how far apart the cameras are allowed to be with restrictions in the size of the wall or the placement of this point.
Thank you, Riley. Here's a quick demonstration of how our software works. We've marked out the exterior walls of our property, and we've marked an important object like our cars. And when we hit submit, we got the location and the area that 2 of our security cameras should be at. Right now, our project currently uses predefined objects, but in the future, we want to use AI to assign value to these. Because right now, these are hard-coded, but we actually designed a basic AI to just assign a number to any object that we give it. And in the future, we want to use a Llama 2 model to have a more accurate model and use more test cases. And in the future, we want to, instead of just using an image, we want to integrate it with Google Maps or any other mapping software so that it can be used for any location.